dear students, very good morning all of you. Dear, here I am going to start the 10th physics, that is topic name is resistance. Okay, of course in class 10th B I have completed the topic potential and potential difference, and as Parvat has confirmed me that he has taken the topic resistance in the class of sections 10th A. Dear, I am just starting from this topic, okay, and I hope you will feel better to recap it. Okay, dear, just we will understand this topic resistance. What it means. First of all, a question in our mind should be, what is resistance? And which material offer more resistance? Which material will offer less resistance? This concept will explain us which materials will offer more resistance and which material will offer less resistance. Okay, dear, as we have already known about that and knowing about that, because from class 6 we are just starting the topic current and learn from there. Those substances, those materials which conduct electricity is called as a good conductor. Okay, and those substances and those materials which do not conduct electricity is said to be as a bad conductor. Okay, so of course those substances which have good capability of conducting current should have less resistance. Okay, resistance is the what physical thing that offered by the movement of electrons inside the conductor. Okay, the movement of electrons inside the conductor faces problem while just colliding with the positive ions of the conductor. Okay, and this causes friction which offer the resistance. Okay, so resistance is the what properties of material. It is the properties of material which is being offered by the material when the electrons flow inside the material, what collides with the positive ions of that materials. Okay, it means what amount of the positive ions overpresent there and what amount of the electrons flowing over in the conductor. Okay, collision is higher. If collision is higher, then the resistance offered will be more. If collision is less, then the resistance offered will be less. Dear, come to know that. If you are taking any metallic substances almost a good conductor. Okay, that's why I am taking a metallic substance. Okay, and if you are taking a metal, you will realize that in a microscopic level there is some positive charge inside this. Okay, and lots of negative charge, that is electrons moving randomly here and there. Okay, there is a random lots of electrons. I am just showing you by E. Here E is what electrons and positive ions. Positive ions means proton, you may say that. Okay, nucleus. So nucleus you may say that, proton you may say that. Simply it is a positive ions and electrons just revolving around this, and these electrons, as it is a metallic shape, okay, move from here to there. Okay, this movement is random. The movement of electron is random. It is collided by ions, electron collides with itself, another electron, and this offered a large amount of collision. This causes a large amount of collision, and this causes what? Friction. As electrons are moving and colliding with another electrons with positive ions, and this offered resistance. And this collision cause what? Less movement of electrons, almost no movement of electrons. Here, understand? Here is the velocity of electron. Velocity of electron is approx 10⁴ meter per second. With this much speed, electrons move inside the matter. Okay. With this much speed, electrons moves, and though causes no current, फिर भी कोई करंट कॉज नहीं करता है. इतने स्पीड से मूव होने के कारण भी तो होता क्या है? What happens? Okay, just come to understand it. Because when it moves with this fast, this fast velocity, this much fast velocity, okay, they collide with each other, and the average velocity becomes zero. Average velocity of electrons becomes zero. Average velocity of electrons becomes zero. That's why there is no current caused. There is no current flow inside the materials when it is what? Just put simply. Okay. Then a question in our mind that when current will flow through the material, when current will flow through the conductor. कोई भी कंडक्टर होगा, उसको सिंपली ऐसे रख देंगे तो इससे करंट नहीं फ्लो होगा. दो द स्पीड ऑफ द electrons are too high, that is 10⁴ meter per second, though there is no current caused, because their average velocity becomes zero, because they randomly collides with each other and causes average velocity. Sum of all the velocities of electrons is zero. So there is no current caused by this electrons movement. Okay. So a question that when will a current conducted through a conductor? Just come to answer. When we apply some potential difference across the conductor. When we apply some potential difference across the conductor. अगर मैं कंडक्टर के क्रॉस एंड में एक पोटेंशियल डिफरेंस अप्लाई करता हूं, पोटेंशियल डिफरेंस that I am showing it a battery, a cell you will take also. Okay, if you are applying potential difference across the end of the conductor, what will happen? Here understand. As it is the positive terminal of the battery, as it is the negative terminal of the battery. Okay, positive terminal will be here. Okay, negative terminal will be here. Okay, come to the point. What will happen next over here? Again, this positive ions will be on their place because they don't move. Positive ions will be on their place, but the negative ions will move. Okay, negative ions will move, but they move in an arranged way. Now they will not move in a zigzag motion. Here the electrons motion was zigzag. Random. It was moving here and there and just colliding with each other. But here, if we are applying some potential, across the end of the conductor, the electrons will move aligned in a queue. Okay, in a queue. They move in a line. And its speed decreases. Its speed decreases. Now its velocity becomes 10 raised to minus 3 meter per second. Means what it happens if we are applying potential, why electrons are just moving. Here I am just changing here. Just changing the sign. Okay. As electron moves from negative terminal to positive terminal and current moves from positive terminal to negative terminal. As I mentioned the direction here, that's why I change the terminal. Okay. Okay. Conventional current direction flow, you know that. Okay. Come to the point. What happened? Now the velocity has been decreased to 10 raised to minus 3. Here the velocity was 10 raised to 4. Though the speed is very less by applying the potential, current will flow because of drift velocity of electrons. Because of drift velocity of electrons. Here the velocity of electron will be called as drift. Electron. But a large amount of electron just moving in a cube very slowly, just moving in a cube and producing current. Okay, it is a similar phenomenon as you people just moving randomly, roaming randomly in the school campus. Okay, but when you see that your father has come over there and you people become disciplined, aligned and move slowly. Okay, simply happens here. The potential is applied and this potential, what by showing this potential, these electrons have aligned and move in the cube with very slow velocity and causes current with decreasing less collision. It means not that over here a large amount of collision will happen. Okay, it means not that there will be no collision over here. There will be some collision. Okay, and that some collision causes resistance. Okay, that some collision causes resistance. So resistance is the property of a material in which electrons flow and collide and often cause field hindrance, and this is called resistance. Okay, I hope you will get this concept there. Okay, so what is the unit of resistance? Just one minute. Ohm is the scientist who has developed this. Okay, so SI unit of resistance is ohm. SI unit of resistance is ohm. Okay, ohm. SI unit of ohm. Okay, it is symbolically written as okay, ohm is represented by this letter. Okay, now define one ohm. Define one ohm. We will define one ohm by understanding the Ohm's law. Okay, After this concept, we will learn Ohm's law. Okay? And Ohm's law, in this way, we will understand the what concept of Ohm's resistance, 1 ohm, okay, and potential combination. Okay, come to the point. What was the statement of Ohm's that become later Ohm's law? Okay, what Ohm's has make us understand? Just come to the point. Ohm's law. State that current flowing in the conductor is directly proportional to the applied potential. Dear, just understand it. What Ohm's has stated. Ohm's stated that he has done experiment on each and every materials, okay, and explained that what amount of potential you are applying to the conductor, across the conductor, that potential is directly proportional to current produced in the conductor. Okay, means he has simply said that this statement was simply written as the amount of potential applied to the conductor is directly proportional to current flowing through the conductor. Okay, means if you are taking a conductor, okay, and you are applying potential, some potential across this conductor, V, let's suppose that positive terminal, negative terminal, current will flow from positive terminal to negative terminal. Okay, current will flow from positive terminal to negative terminal. Okay, like this. While electron will flow from negative terminal to positive terminal. Okay. So here is stated that by changing the conductor, replacing it, he has found that in each and everywhere, if you are applying potential, current in the conductor will increase. Current in the conductor will increase. If you are decreasing potential, current in the conductor will decrease. Means he has explained like this. Like this. Let's suppose that there is a current graph and there is a potential. If you are increasing potential, let's suppose that 1 volt. 1 volt. On 1 volt, if you are finding 2 ampere current, ampere volt. Okay. 1 volt, 2 ampere. 2 volt, 4 ampere. Okay. Means let us increasing like this. Again 3 volt, 6 ampere. Let's suppose he has observed that a straight line uniformly means relation between current and potential was explained by Ohm's directly. Okay, directly. Okay. For removing this proportionality sign, we have to apply some constant. Okay, V is equal to, if you are removing this proportionality by equality, you have to implement some constant, and that constant is R. resistance. That constant is R resistance. Okay. So what he has explained? He has explained that V upon I is equal to constant, and that constant is resistance. Okay. So V is equal to IR. Here I is current. Current in the conductor. V potential across the conductor. Potential. And R resistance. Resistance across the conductor. Resistance offered by the conductor. Different material have a different resistance. Okay, because it is a material property. Resistance is a material property. Different material has a different resistance. Okay. So how we will define 1 ohm? Dear, come to the point. So we have a formula. V is equal to IR. We can write it like this. V is equal to IR. So R is equal to V upon I. If you are applying 1 volt potential across a conductor, if you are applying 1 volt potential across a conductor, and current flowing through the conductor is 1 ampere, and current flowing through the conductor is 1 ampere, then we say that resistance offered by the conductor is 1 ohm. Then we can say that resistance offered by the conductor is 1 ohm. I hope that you people understand this concept of 1 ohm. 1 ohm. Once again, just see it. Once again, 1 ohm. When a conductor is being applied across a potential of 1 volt, if you are applying 1 volt across the conductor, okay, and 1 ampere current is flowing through the conductor. 1 ampere current is flowing through the conductor. 1 volt, 1 ampere. This will offer 1 ohm resistance, since the conductor has a resistance of 1 ampere. Okay, I hope that you get it. Okay, dear. Resistance is a material property. Different material has a different resistance. Okay. For example, our body has an infinite resistance, so that current cannot flow from our body. Okay, dear, just understand it. It has a high resistance body. Okay, like plastic chair. Okay, wood, through which we cannot flow that current. Okay, that's why it is a bad conductor. Good conductor, copper, silver, aluminum. These substances are a good conductor. Okay, there is a less resistance offered by these materials. That's why we can say that it is a good conductor. Okay, so I hope that you get it. Next class we will understand resistivity and the properties of material. Okay, thank you. Bye.